Today, we will look at how to draw Bohr-Rutherford diagrams from information we get from the periodic table. So let's see. When you want to draw a Bohr-Rutherford diagrams, you have 3 steps to do. The first one, you have to find key information about your atom. That means you need to figure out how many protons, how many electrons, and how many neutrons there are in your particle. Second, you have to trace the nucleus, which is you trace a circle, and in that circle, we will add how many protons and neutrons there are on that specific atom. And third, we need to add the electrons in the proper places. And what's interesting, we cannot put all the electrons all at the same time at the same place. There's no room because the electrons are repelled from each other. So that means that for each of the levels we are using with, the first level has 2, second level has 3, and the third level has 3 electrons. So we're going to take a moment to try to better understand that in this video. So to start, we need to pick, let's see which one we're going to take. Let's take sodium this time. Actually, let's take lithium. No, I don't like, let's see. Yeah, lithium is easy. Let's start with an easy one. I think that's beautiful. So if you are looking at the lithium element, I'm going to write on the board the information that is located right here. So we have here an atomic number of 3, and we have an atomic mass of 6.94. So if you look at the information from the periodic table, we know that we have an atomic number of 3. That means that I have 3 protons. And we're dealing with the neutral atoms right now. That means that the number of protons and neutrons are exactly the same. Now, if we're looking for how many neutrons we have to look at the mass, at the atomic mass, and then we round it to the closest whole number, which is here 7, and that gives us the mass number. If I want to know how many neutrons I have, I take the mass number minus the atomic number. And that gives me 3 neutrons. Okay, this information is very important because it allows me to know, first of all, if I want to do the Bohr-Rutherford diagrams, I need the info. Second, let's see if we can put it together. The second step, we do the circle, and then we put inside how many protons and neutrons we have. So here you will see that I put the number of protons at the top. I put there's 3 of them. I always put P, meaning protons, and here there's a charge positive. It makes it easier to see what I have. I have 4 neutrons. N stands for neutron, and the 0 here stands for the fact that neutrons don't have a charge, they are neutral. Once I have this one here, I have to go to the third step, which is to add the electrons we need. And here we know we have 3 electrons. From the information I have here, I have 2 electrons on the first level. And then if I have more than 2, I go to the second level and the second energy level. Like this. Perfect. So here I have a very good Bohr-Rutherford diagram. I have the nucleus that tells us how many protons and neutrons I have. I have here a full, like a line here that is full, that is solid, that allows me to tell me that this is the nucleus. And I use dashed lines all around. Knowing that I have 3 electrons, I put 2 here and then the third one on the following level. So let's see. So this is one way to do this. Every so often in class, I add one thing that is different here. And instead of using little circles, when I have a good pencil, a good pen, there we go. I put a little e with like a lowercase e and a negative sign. And these represent the electrons. That's a great way to be able to see how it goes. So this is this one here. We're going to take a moment and we're going to do aluminum as our second element. So give me a second. I'm going to gather the information for aluminum. And in the meantime, I'm going to give you a chance to see on the screen what you have. Let's see if we can look at the information we get from the periodic table. Knowing that the atomic number is 13, that gives us the identity of the atoms. And we know that with an atomic number of 13, there are 13 protons. And because we're dealing with here neutral particles, we also have 13 electrons. Protons, like this. So here we have already information about our first two particles. The next one, I want to know how many neutrons we have. So in order to do this one, I need to look at the atomic mass, and I need to round this number to get us to the closest or the nearest whole number. So since I have a 26.982, to round this number, I have 27. In order to find how many neutrons I have, I will take 27 minus the atomic number. That gives us, let's see, that gives us 14. So from this key information, we know that there are 13 protons and 14 neutrons in the nucleus, and I have 13 electrons to play with. Let's see what we're going to do. When I want to put together the Bohr-Rutherford diagram, first thing I need to find the key information, which I have right now. Second, I'm going to trace the circle to represent the nucleus and put the necessary information, or the available information. So I know I have 13 protons and 14 neutrons. So very good, we're halfway there already. The next one is to put the electrons. So electrons will be on specific level of energy. Some people call them shells. That's the way to look at it. So how many electrons can we put on the first layer? On the first shell, we have 2 electrons. So we have 1 and 2. Now we're going to go to our other. Now that we have 13, I have to go 1 extra layer. So here I'm going to give some spots so that we can write them down nicely. So here I'm going to add electrons. So the first is here. We have our second, third, and fourth. Keep in mind that the electrons are all negatively charged, and therefore they want to be as far away as possible from each other. I have 4 plus 2 is 6, but I need to put 13. So how will we do that? We continue. So 4, we have 5, 6, 7, and 8. So in the aluminum atom, we have 2 electrons on the first layer, first level, 8 electrons on the second level, and that makes us 10 that we can account for. However, we have 13. So that means that if I can put 2 on the first level, 8 on the second level, I'm going to have to add another level. And here I will add the 3 electrons I have extra. 1, 2, and 3. And here is an excellent representation or excellent Bohr-Rutherford diagram of what? Of an aluminum atom. So this is excellent here. So here we're going to do with our third, the third one. And let's see if I can do, I'm going to do argon. I think argon is very nice. I'm going to show you the information that will give me a chance to draw argon here. Now let's look at the information I have about argon. Argon does have 18 as an atomic number. That means that each atom of argon will have 18 protons. And because we're working with neutral atoms right now, we have the same number of protons and electrons. So here, great information so far. I want to know how many neutrons we have. We're going to go, we have an atomic mass of 39.948. I'm going to round this number to the nearest whole number, which is 40. And I therefore have my mass number, which is 40. If I want to know how many neutrons I have, I'm going to take the mass number minus the number of protons, or the mass number minus the atomic number. So from what I can see, I have 22 neutrons in an argon atom. So let's see if I can do the Bohr-Rutherford diagram of this atom. So here, if you look, we were able to find the first piece of information, which are the information about my atom. Second, I'm going to do the circle that represents the nucleus. In the nucleus, I have two subparticles. The first ones are protons and the second ones are neutrons. Keeping in mind that we have information about them, let's add them in the nucleus. Protons and 22 neutrons like this. Perfect. So now we have our nucleus. Now we have 18 electrons that we need to place. So let's see what we've got. We're going to put the 2 electrons on the first level, 8 on the second, and guess what? Since we have 18 electrons, we're going to be able to have a full shell of electrons. So let's see if I can do that for you. So second and third. So let's put little numbers, a little circle like this. I think that'll be fun. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Excellent. This is an excellent Bohr-Rutherford diagram. And on top of that, as you can see, we each have enough electrons to fill all of these energy level, which is amazing. Now, there's something that we have to look into, and I'm going to look at the periodic table with you, and let's see if we can figure out what happens if I forget how many electrons go on each of the energy level, or how many electrons are in each of the shell. So let's have a look at the periodic table. So here we're going to look at the different groups that we have. If you look at the first group here, which is the first row, no, sorry, it's not the first group. It's called, let's see. Oh, yes. If we look at the first period, which is the first row right here, we see that we have 2 elements with hydrogen and helium. That means that we have only 2 in the organized periodic table. That's our clue that we have 2 electrons on the first energy level in the first shell. And guess what? When I go to my second shell, the second level, we end up with our second period. But look how many elements we have. We have lithium, beryllium, bore, carbon, nitrogen, oxygen, fluorine, and neon, which are 8 elements. So here, the periodic table is organized so that the second period tells us that we have 8 different elements, and that tells us that there are 8 electrons that go on the second energy level, on the second shell. Now here, if we have the third period, guess what? We have sodium, magnesium, aluminum, silicium, silicon. I have phosphorus, sulfur, chlorine, and argon, which are our 8 elements here. That reminds us that we have, if you look here, 8 electrons on the third shell right here. So this is something that is interesting. Now, some of you will say, well, does that mean that when you have on the fourth period, we have 18 electrons, that we have 18 in an outer shell? Well, that's a good question. In grade 9, we are looking to elements all the way to calcium, because from the atomic number 1 to 20, it's very similar with respect to the outer shell, with respect to where electrons are. Now, as we go to number 21 and we go into the transition metals, then things are a little bit different. But in grade 9, we're not going to worry about it. That's something that you will learn in grade 11 and grade 12 when you start thinking about orbitals and where the electrons are surrounding the atoms. But that is not something we're going to worry about in grade 9.